Shot heard around the world, polio vaccines and a medical revolution. This is not a musket shot, but a medical one. The development and distribution of the polio vaccine sparked a medical revolution that transformed disease prevention. This revolution triggered intense public and political reaction, and ultimately led to lasting reforms in public health policy, scientific research funding, and mass immunization systems in the United States and around the world. Poliomyelitis, commonly known as polio, was one of the most feared diseases of the 20th century. Its unpredictable nature fueled panic and shaped most of the public reaction to the disease. Polio often began with symptoms so mild they seemed harmless, fever, fatigue, and headaches, but the virus was deceptive. The virus could reach the central nervous system, attacking nerve cells responsible for muscle control and leaving many victims with permanent weakness or paralysis.
For my grandmother, Donna Clover, polio was not just a disease, but a battle she still fights to this day, because the fight did not end when the virus left her body. Over the course of her life, she underwent multiple surgeries to manage the lasting damage. As she recalls, "My third surgery, I had to have my ankle and most of my bones in my foot fused to alleviate the foot drop and intense pain." Donna was not alone. In 1952, the United States reported 58,000 cases. Over 21,000 people were paralyzed and 3,000 died. Even after the surgery, the challenges continued. She explained that she had to relearn how to walk and rely on braces for years. "After that surgery, I had to continue to walk with a leg brace and corrective shoes until I was 5 years old, and again later in life." Decades after surviving the initial infection, new complications emerged. Post-polio syndrome has affected my entire body. She said, "I have joint pain throughout my body, weakness in all my muscles, and shortness of breath." Yet despite these lifelong challenges, her story is one of resilience. As she put it, "I still continue to thrive and do not consider myself as being handicapped." As polio tore through communities, the fight against the disease gained a powerful leader, President Franklin D. Roosevelt, who had been paralyzed by polio years earlier, used his personal experience to drive national reaction into action. In 1938, he founded the National Foundation for Infantile Paralysis, later known as the March of Dimes. Instead of relying on wealthy donors, the organization encouraged millions of Americans to contribute small amounts.
This organization reformed medical research funding and created a nationwide movement. What made polio especially terrifying was who it targeted. Nearly 65% of cases occurred in children, many of whom were previously healthy. Parents watched mild symptoms turn into paralysis within days, with no way to predict who the virus would spare. By 1952, polio reached its peak in the United States. Fear dominated public life, public pools, and parents kept children indoors, and there was still no cure in sight. However, the scientific groundwork for stopping polio had already been laid years earlier. In 1949, scientists John Enders, Thomas Weller, and Frederick Robbins made a critical breakthrough by successfully growing the polio virus in non-nervous tissue cultures, like skin and muscle. Before this, viruses could not be reliably grown outside of living animals, severely limiting research. Their work transformed virology and made large-scale vaccine testing possible. As news spread that a vaccine might soon be developed, public reaction was mixed. A 1954 poll revealed that only 60% of Americans were certain they would take the vaccine, while 31% said that they would not, and 9% remained unsure. Many feared the vaccine due to distrust of new medical technology and Cold War anxieties, shaped by the recent use of science to create atomic weapons.
This hesitation revealed a critical tension. Americans desperately needed protection from polio, yet their fear slowed acceptance of the medical breakthrough. While public reaction remained uncertain, the fight against polio was already underway. In 1953, Dr. Jonas Salk and his team at the University of Pittsburgh began developing an inactivated polio vaccine. This revolutionary approach used dead polio virus to simulate immunity without exposing patients to the live virus. Dr. Salk even tested it on himself and his family, demonstrating confidence in its safety. In 1954, the Salk vaccine entered field trials and was the largest medical experiment to date, beginning on April 26 at the Franklin Sherman Elementary School in McLean, Virginia. The trials ultimately involved 1.8 million children across the United States. This massive effort marked a turning point in public health. On April 12, 1955, the vaccine was declared safe and effective. Others questioned whether the vaccine's rollout truly represented smooth scientific triumph. Just weeks after the announcement, the Cutter incident occurred, in which improperly inactivated vaccines batches led to cases of paralysis in about 200 recipients.
For some Americans, this crisis suggested that the polio vaccine exposed weakness in public health systems rather than proving their strength. These critics argue that the scientific method was flawed and that confidence in vaccination programs had to be rebuilt through stricter regulations and improving manufacturing standards. They argue that the vaccine revolution itself was imperfect. Although the Cutter incident exposed serious flaws in vaccine production, it ultimately strengthened public health systems. In response, the federal government implemented stricter vaccine regulations and oversight, creating safety standards that are still used today. This crisis led to reforms that improved medical accountability and increased long-term public trust in immunization programs. Within months, the polio vaccine became standard for children.
The impact was immediate. By 1957, annual polio cases dropped from 58,000 to just 5,600. This success proved that widespread vaccination could dramatically alter the course of the disease and led to sweeping reforms in public health strategy. Despite the success, scientists recognized eliminating polio worldwide would require vaccine that was cheaper and easier to distribute. In 1958, Dr. Albert Sabin and a team of Russian virologists conducted field trials of a new oral poliovirus vaccine in the Soviet Union. This vaccine was easier to administer and far less expensive, making it ideal for global use. The results were, again, revolutionary.
In December 1959, Hungary became the first country to implement the oral vaccine nationwide. Czechoslovakia followed soon after and became the first country in the world to completely eliminate the polio virus. These successes sparked international reforms in vaccination policy and demonstrated the power of global cooperation in public health. As more countries adopted mass immunization programs, the National Foundation for Infantile Paralysis helped distribute vaccines both within the United States and globally. The results exceeded expectations. By 1961, there were only 161 cases of polio in the United States. By 1970s, that number dropped to just 12. In 1979, the United States recorded its last case of wild polio, otherwise known as polio contracted naturally. The impact of the polio vaccine extended far beyond the disease itself. The reforms sparked by this medical revolution permanently reshaped public health. Large-scale clinical trials, first perfected during the 1954 polio vaccine trials, became the standard for testing vaccine safety and effectiveness. Government funding for medical research expanded, and mass immunization campaigns became an expected responsibility of public health systems rather than an emergency response.
The methods developed through the inactive polio vaccine, or IPV, are still used today. Jonas Salk's approach of using dead virus to safely stimulate immunity continues in modern medicines like hepatitis A vaccine and some influenza vaccines. These vaccines rely on the same principle pioneered during the polio era, protecting patients without exposing them to the live virus. At the same time, the attenuated virus strategy developed by Albert Sabin also became a lasting reform in vaccine science. Sabin's oral poliovirus vaccine used a weakened form of the virus to build immunity and stop transmission. This revolutionary method remains in use today in vaccines like measles, mumps, and rubella, commonly known as the MMR vaccine, as well as varicella or the chickenpox vaccine.
Mass vaccination campaigns, once held in school gymnasiums, are now routine in pharmacies and clinics, reflecting lasting reforms that emphasize prevention over treatment. The fight against polio stands as a defining example of how a medical revolution shaped by public reaction can lead to an enduring reform, changing not only how diseases are prevented, but how governments, scientists, and communities work together to protect public health.